In this video, we're going to define and identify like terms and non-like terms. We'll then apply this to a process known as combining like terms. So to start, like terms are terms that contain exactly the same variables raised to the same exponents. So we'll write that down. Like terms are terms that contain exactly the same variables. And I'll write this with as variable or variables, which I can write with variable and then s in parentheses. So exactly the same variable or variables raised to exactly the same exponent. Okay, so with that in mind, let's look at a few examples of like terms. So a simple example, let's say that our variable is x and we have it raised to the first power. So two like terms with just the variable x, we could have 5x, or let's even make that negative 5x, and let's do 3/7 x. Those would be like terms. So looking at them, the reason that they're like terms is that they both contain x, and the exponent, which we don't have to write on x, is that implicit 1. Their coefficients in this case are -5 and 3/7. The coefficients don't affect whether or not the two terms are like terms. It's only the variables and the exponents on those variables. So another example would be something like y squared, and let's do 4y squared. So here, each term has y raised to the second power, so the same variable raised to exactly the same exponent. And the coefficients here are 1 and 4. And again, the coefficients don't affect whether or not the terms are like. It's the variables and the exponents. For our next example, let's do one with the variable x and y. So let's take 3xy and let's take 1/2 xy. So we have x raised to the first power and y raised to the first power in each of those terms. And for our last one, let's do two constant terms. Let's take the number 8 and the number -31. So those are both constant terms or just numerical terms. We'll look at a few examples of non-like terms real quick. So if to be like terms we have to have exactly the same variable raised to exactly the same exponent, then non-like terms will be any two terms that don't have exactly the same variables or have the same variables but raised to different exponents. So a quick example, let's take -5x, and then let's do something like a constant term 7. So 7 doesn't have the variable x raised to the first power, so it's not a like term to the term -5x. Now let's take y squared, and let's change this next one to 4y. Now they're no longer like terms, they both have y, but the first term has y raised to the second power, and the second term has y raised to the first power. As another example, we could do 3xy, and let's just do 1/2 x. So each of these terms has x raised to the first power, but the first term has y raised to the first power, and the second term does not contain y, so those would not be like terms. Now, anytime we have like terms, we can add or subtract those two expressions and combine them. So if we look at this first example, we have 12x plus 8x, and we know that 12x and 8x are like terms. They both have x raised to the first power. So conceptually, I can think of 12x plus 8x as 12 of this thing and 8 of this thing, and I've added them together. So total, I should have 20 of that same thing. So looking at that, I would write that out as 12x plus 8x, and that'll equal 20x. And that's just conceptually thinking, I have 12 of this thing and 8 of this thing, and they combine to 20 of it. The algebra behind that, I'll show it real quick. It's actually using the distributive property in reverse. So I have 12x, and I have 8x, and so that's 12 plus 8 of this thing called x, and if I simplified that, I'd get 20x. Looking at this next example, 8x minus 8y, I first want to ask myself, are 8x and 8y like terms? And the answer here is no, as the first one contains the variable x and the second one contains the variable y. So for the second example, this cannot be simplified. So I'll just write that here. In this third example, I have the expression 2t minus 5t. I know that 2t and 5t are like terms. So to combine them, I can conceptually think about having 2 of this thing, t, and 5 of it, and I'm going to take 2t and subtract 5t. So when I'm done, I will have negative 3t. If I want to look at the algebra behind why and how that works, again, it's that distributive property in reverse. So I have 2t minus 5t, and that is 2 minus 5 of this t, which is negative 3t. And in this last example, I have 3x squared plus x. The first term, 3x squared, has x raised to the second power, and the second term, which is just x, has x raised to the first power. So those are not like terms, and this cannot be simplified then, which I'll write down. So we've defined like terms, identified like terms and non-like terms, and then used what we know about like terms to simplify expressions by combining like terms.